Okay, start recording. Hello YouTube. Let's go, exercise 10. Syntax scoring. You ask the submarine to determine the best route out of the deep sea cave, but it only replies, syntax error, in navigation subsystem online, all of them. All of them? The damage is worse than you thought. You bring back up a copy of the navigation subsystem, your puzzle input. A copy of the navigation subsystem. Okay, anyway, like documentation, source code? Well, I don't know. Navigation subsystem syntax is made of several lines containing chunks. There are one or more chunks on each line, and chunks contain 0 or more other chunks. Adjacent chunks are not separated by any delimiter. If one chunk stops, the next chunk, if any, can immediately start. Every chunk must open and close with one of 4 legal pairs of matching characters. So if a chunk opens with a normal parentheses, square brackets, curly braces, diamonds. So open close parentheses is hey Matt. Is a legal chunk that contains no other chunks, as is square brackets. More complex but valid chunks include okay, and even okay. Some lines are incomplete, but others are corrupted. Find and discard the corrupted lines first. A corrupted line is one where a chunk closes with the wrong character. So that is where it's a line that you cannot fix by closing whatever open parenthesis was remaining. So yeah. Examples of corrupted chunks include okay. Such a chunk can appear anywhere within a line, and its presence causes the whole line to be considered corrupted. For example, consider following holy shit. So basically my puzzle input is a C++ template error, and you need to parse it. Okay. So for the first incorrect closing character on each corrupted line, did you know that syntax checkers actually have contests to see who can get the higher score for syntax errors in a file? It's true. To calculate the syntax error score for a line, take the first illegal character on the line and look it up in the following table. Parentheses 3 points, 57 points, square brackets. Why is this one getting so many points? In the above example, an illegal parenthesis was found twice. Expected but found. Okay, so it's the one that you found that wasn't supposed to be there. So I found twice, so you add the same amount twice, blah 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 blah. So the total error score in this file is this one. Find the first illegal character in each corrupted line of the navigation subsystem. What is the total syntax error score for those errors? Yeah, I think your C++ release transpire has a bug or two. Okay. Let's do it. Oh, I should do just 10. Yeah. Okay. Okay. So we can close this from yesterday, close without saving. Let's copy over some stuff. I think I'll need some of this stuff. So basically we need to have a stack, I guess, and we push every open parenthesis we find, and we pop when finding a closing parenthesis, and it has to match, and if it doesn't match, then that's when we stop and start counting points. And we do this for every line. And since we don't care about lines that are incomplete, we don't care if, like, at the end of the process there's still parentheses in the stack, and that's it. Okay, let me think. Is there any weirdly clever way of doing this? No, because it's nested stuff, and when it's nested, you have to keep track of the nesting. Unless everybody always did it wrong with, like, real programming languages and never realized that you could do it in an easier way. Okay. So this exercise seems reasonable. And the fact that we are not doing anything about open, like incomplete lines, makes me think that we're gonna do that in the second part. So that also seems reasonable. I'm looking forward to see if there's any twist or thing that I didn't expect that's gonna bite me in the ass. I think we can basically do a stack with an array list, right? We append and pop. I need to double check if array list has append and pop, and I'm pretty sure it does. So let's go look at the implementation of array list. Array list. Pub function append. There we go. Pub function pop. There we go. Removes and returns the last element from the list. Asserts the list has at least one element. Oh. So here's the interesting thing. I think that some of the errors could even be errors of too many closing parentheses. So this one, basically, this is a pop that's gonna crash if we try to pop wrongly. We don't want that. I think we want pop or null, where we want to pop, and if we get null, it means that we try to pop. It means that there are too many closing parentheses, which I think it's an error. So what we want is pop or null. That's my hunch. So this is gonna be, I don't know, stack. I can't think of a better name for it. So let's start tokenizing, right? So we tokenize as usual bytes, input. In this case, we want lines when tokenizing, because then we operate character by character. So while it.next gives us a line, while it.next gives us a line, we want to loop over each character in the line and do stuff to it. Can we do straight up a for and then a switch? Can we do this? It's a cute way in which you can, like, chain these things. Oh, but that makes the for an expression. Or it makes the switch an expression. I don't know, it makes everything an expression. Whatever. So we get the character, and we need to decide what to do in each case, right? So if it's an open parenthesis, we need to do something. And actually, you know what? I think we can do it even like this. We can basically have a case for all the opening parentheses, like this, I think. The problem is that we still need to distinguish between them, but we can use C. So normally, yeah, we can use C to refer to which one specifically it is. So if it's an open parenthesis, we just push it to the stack. I think this needs to be tried because it needs to allocate memory. And if we find one of the closing parentheses, then we, oops. Then we need to pop from the stack, and we can and we need to use pop or null, right? So we try to pop from the stack, and we get back an optional. I think that if you push the closing parenthesis on the stack, you avoid an extra switch. I'm not sure I understand what you're saying, Boomerang. Because, like, right now, I don't know if you're thinking, I'm on the first half of the exercise, by the way, just to make sure about this. I don't know if in the second half you need to do something different, but right now, I don't think I need to do that because... let me continue a little bit. Maybe I realize what you're saying afterwards. So we try to get an open parenthesis, and if there is none, so we also have the else case in case we got null, and so we know that actually let me put a std.print here. I knew it. This is just to say because I'm not sure, the problem definition doesn't seem to imply that there can be too many closing parentheses, but this might be information that the exercise description is purposely not trying to be super clear about. So I just want to see if we ever land in this case. Okay, so we have an open parenthesis and we need to check that they match. I think if you push the closing parenthesis to the stack, you avoid an extra switch. Okay, now I think I have a switch or something, right? Because now I need to know if they match. How can I make them match? I think that in ASCII, closing is like opening +1, right? I'm actually not sure about this. So let me go check in the ASCII table, whatever. Yeah, I don't want more details. I just want to see the full picture. God fucking damn it. Oh no, of course, equal is between lower and greater than. So that's not gonna happen. Oh! But there is... Also, what the heck is this? Glyph 96... What? 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 What's going on? Are there been different editions of this standard? Please don't. I think we're using the middle one, right? We're not. Are we using the right side one? Well, at the end of the day, it doesn't matter because so these all are two. They all have something in the middle. This also has something in the middle. Where's the round parents? And fuck, of course the round parents don't have anything in the middle. So you can't use the same, like, -2 to go from one to the other. So close. Spec committees are ruining our lives. Oh, why didn't they make the spec easy for me to solve an exercise for a advent of code thingy? Maybe not the most valid complaint, but still. Okay, so we finally open parentheses, and I guess we need to switch again. So maybe this is what Boomerang was referring to. Although I don't see how to make this easier. Ooh, Benjamin. Let's go, Benjamin. I like this. I love this. It's more like I should do it with the open. No, I should do it with the closed parentheses. If C is a closing parenthesis, then we do C plus equals oh, we can do plus equals 1 though, because it's immutable here. I could ask a mutable pointer to it. Is it even worth it? My suggestion was open parentheses, try stack append closing parentheses. Oh, I see. Like, we don't append the real parentheses, we append the closing parentheses directly, but then you can just do equality on the closing. I mean, you kinda move this mapping in the opening, right? Because here I'm already squishing these cases together. If I do this, I can't do this, right? I can do it with math though. Okay, so I think so. By combining your suggestions, I think I can make a monster. Thank you, Boomerang and Benjamin. So here's the idea. I can't modify C because it's immutable, but I can make another variable for it, I guess. But what if I make something worse? And here's what I do. When I append, if C is an opening parenthesis, I append C plus 1. Else, I append C plus 2. And now, I can check for equality. So if so now if C matches, then I already know that this is gonna ruin my life in part 2. But hey, so if C equals open, which was never open at all. We always put the closing version of it. Whatever. Then if it matches, then we're good. If it doesn't match, right? So C is different than open. Also, K Shiba, hello. Sorry, I didn't greet you earlier. Don't forget diamonds. Oh, thank you. Right. I think I would have found them when I would have gotten the else branch compile error thingy for the switch case, but yeah, absolutely. Else unreachable, and this is actually a good unreachable because it's really unreachable, I think. So what if the two parentheses don't match? Or you know what I can do? Here's what I'm gonna do. If they do match, continue. So if there is something to pop, oops, thank you. So if there is something to pop and it's up and it matches, then we pop both, we're good, and then we continue the for loop. Otherwise, we fall through. And with the fall through, so this algorithm is becoming better and better. I love falling through. I think it makes everything better. Hey Lightbook, thank you for follow. Welcome to the stream. So, man, how to make everything worse. So we fall through, and what do? We need to count points, right? So score starts at 0, and here we do score plus equals switch what? C, and based on what C is, then we decide the points. We should introduce break to branches, then we'll emulate C switch fall through. Nice. Okay, so 357. It's going to complain about types, isn't it? I know it already. 1197. I think I'm going to copy paste the final one. Okay, let's see the compile error and then I'll see what to do about it. Zig run main.zig. Switch must handle all possibilities. That is indeed true. Also, else unreachable here then. Cannot store runtime value in comptime int. Wait, what? Okay, because this is the switch thinking about this stuff, not score. Score is a usize. And I think this should automatically fix the whole switch. Okay, it runs, doesn't print anything because we're not printing. Oh, wait, it doesn't print. I knew it. So it turns out there is never anywhere an overabundance of closing parentheses. That's kind of sad. Also, wait, we do this. We found a bad one, and that's when we stop. So with this, we break. We break from the for loop. We are done with this line. Okay, and the score is printed after we're done with the while loop. Four, 4, 1, 4, 7, 1. Let's see. Yay, right answer. So that was easy. Let's see the painful part. Now, discard the corrupted lines. The remaining lines are incomplete. Incomplete lines don't have any incorrect characters. Instead, they're missing some closing characters at the end of the line. To repair the navigation subsystem, you need to figure out the sequence of closing characters that complete all open chunks in the line. You can only use closing characters okay, the outside parentheses kind of make this whole explanation slightly more confused than it should be. And you must add them in the correct order so that only legal pairs are formed and all chunks end up closed. In the example above, there are 5 incomplete lines completed by adding this, that, blah, blah, blah. Did you know that autocomplete tools also have contests? What do you know? It's true. The score is determined by considering the completion string character by character. Start with a total score of 0, then for each character multiply the total score by 5, and then increase the total score by the point value given for each character in the following table. 1, 2, 3, 4. Okay. So start with a total score of 0, multiply the total score by 5 to get 0, then add the value of this. The 5-line completion strings have a total scores as follow, blah 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 blah. Autocomplete tools are not bunched. The winner is found by sorting all the scores and then taking the middle score. In this example, the middle score is blah 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 because blah blah blah. Find the completion string for each incomplete line, score the completion strings, and sort the scores. What is the middle score? Okay. I expected worse, but maybe I'm underestimating the nature of the problem. So, it should go without saying that this insanity that we did right now, it's kinda not gonna fly. So, this used to give us score, now it doesn't give us score anymore. And I think it kinda does the opposite. It tells us which lines we can discard, right? So basically the break is still useful because we are using the break to find a bad line. What we can do is add to the for loop an else branch, and the else branch basically this runs if the for loop what can I find a P? Okay. If the for loop didn't break, that is if it didn't find a bad character. Also, we have another nice property, I think, which right now it means that the stack, or actually, you know what, maybe the garbage thing that we did earlier where we swap parentheses, we can still do it, maybe. Also, I'm realizing something. You kind of want to, you know, well, no, I can initialize it outside, but you kind of want to reset the stack every time you loop. That's actually kind of a problem. I mean, apparently it wasn't a problem when doing the previous exercise, but in this exercise, we kind of want to make sure that we don't keep garbage in the stack from previous lines, right? Although, to be fair, so this is funny because no, in reality, you don't need to do that because previously, maybe we would left some garbage in there, which would waste memory because then you would add like more garbage as you go down the lines, but it didn't affect the final score. Now here, you need to be more precise with the stack, but at the same time, you're going to clean it up every single line. No, you're gonna clean up every single line except when there's a stack in the middle. Also, this could definitely be done without a stack, I think. I'm starting to have second thoughts about stuff, but anyway, we definitely want to reset the stack. So let's look at the function to reset the stack. I don't know how it's called, reset maybe? Clear. There we go, clear and free, clear retaining capacity. That's the one that I like. Basically, clear retaining capacity empties it, but it doesn't free the memory. And that's fine, we want to keep the memory around. We just want to set the counter of how much of that memory was occupied back to 0. So we want stack dot. Oh, of course I didn't copy anything. Clear retaining capacity. There we go. So clear the stack for each line, which is well and good. Then we start populating the stack, and we break the for loop. You know what? I can do this, but also this is so bad and there's no point. So let's change this break to a continue outer. So okay, I kind of wanted to meme with like complex constructs, but there's really no point. We have an outer label, so basically we want to restart the outer loop in that case. No, there's no point in being clever in a bad way when you actually have a better alternative. Just have to reach for it. And this can even be named in a better way. Oops. Okay, so the for loop went and ran. Now we have a stack with all the parentheses that need to be balanced. Wait a second. We don't have all the parentheses that need to be balanced. We have all the closing parentheses. And they are in the reverse order, so we just need to reverse them. And we're good. Like, you do a bunch of things, and then at the end you're left with like with something like this. So you're this. We already have these parentheses in the opposite case because we store them in the opposite case, right? We store them as this, this, and then we only need to reverse it, and we're good. Or iterate from the end, basically. Iterate from the top towards the bottom. This stupid trick actually works wonders. What the heck? So the exercise was saying you take the score for the line. So we need to have a concept of a line score, I think. You multiply it by 5. So let's also do this. Okay, let's rename this to final score, and then var line score 0. So let's take a look at the algo. Two. Yeah. Oh, right. There is not even a total score. Now the final score is like now it's an array list itself. Right, because you have to append them. So you have to compute them and then have to append them. So you have to do something like then there's no point in doing this. Like we can do score. No, it has to be var. So okay, so that line is actually useful. And then for something, we add to line score, and then finally we append line score. Try final score dot append line score. Okay. Okay, let's do this part. So, as I was saying, these are just reverse. So how do we reverse? I would say we iterate from the top towards the bottom. Now, it would be nice if for allowed us to reverse iterate, but we can't. Is the first essential to Z programming? Just asking as a language designer. Hi, Ratatosker. Hello. Is the first essential to Z programming? I would say yes. So you're not seeing me doing this in Advent of Code because I don't really care about like cleanup resources. But let's say for a brief instant that this was actually supposed to be a more serious program, like not just a one-off thing to get a result and then thrown away forever, but it's something that needs to be reused more. So here's what I would do. Here I create a allocator, and right away I can do the fur underscore equal gpa.binit. So the underscore is basically because I'm throwing away the result, because the general purpose allocator gives you some diagnostic information when deinitting. Usually for most stuff that's not the case, but this is a peculiarity. But the idea is, with this, I'm freeing the GPA at the end of the function. I can do the same with the array list. Also, let's say that for some reason, I had to create an array list at the beginning of every while loop iteration, and then I had to do something with this array list, and then I had to free it at the end. I could also do this. So I prepare the cleanup right away in the line right after, and I'm good. And this defer runs once we leave this scope. So every time the while loop restarts, basically we run the init, and or rather, it doesn't have to restart every time we are complete one loop. So it also works in the after final iteration. And so this sets up the cleanup in a very nice way. Hey, Mindstormer, thank you for the follow. Thank you for the raid, and hello everyone. Godwa, hello. Yeah, massive raids, thank you. So the idea is that the fur basically gives you, I think Specs was saying it earlier. Yeah, we don't have distractors. So basically this is like almost distractors, but with no like complexity. Also, the fur goes hand in hand with defer. Defer is for, basically you use the fur for stuff that you allocate and you yourself plan to use until then you need to clean up at the end. But if you have a function somewhere that is like function create device, and a device, I'm making this up. So device gives you a device. I haven't defined what the device is anywhere. So let's do this. Const device struct, and for some weird reason, device is like two array lists, right? I'm making this up on the spot. I don't know. The other one is booleans or something. I have no idea. So to make a device, so here, to make a device, you need to allocate two of these things, right? You need to do this. Well, actually, fuck. Okay, array lists have the problem that they never fail. Like allocating, creating an array list doesn't. There's no try here, so it's not allocating memory yet. I need to find a better example. But let's say that these are two resources that require allocation. Okay. I don't know. And here you'll need to do like var foo equals try allocate foo. And same with bar. And this could be, I don't know, you have to open 2 sockets maybe. Something like this. The problem is, so if everything goes well, you get to the end, and then you return a device that contains foo equals foo, bar equals bar, and you're good. But what if one of the 2 allocations fails? So now you cannot, sorry, and there should be probably a thing that says that this function can fail. So let's say that one of the 2 allocations fails, or one of the 2 sockets that fails to open. Now you cannot return a device anymore because something went wrong, but you still allocated partially something. And here is where defer comes into play. So you do defer foo.deinit. .deinit is like, it's just a convention, it could be something else. But the idea is that you run the cleanup procedure only if you are returning with an error, which in this case is just a try. Or maybe you have something else like, if I don't like foo, then return error dot bad foo. So also in this case, since we are returning with an error, this defer will run, this defer will run, we do the cleanup, and we're good. And this is like what, 90% of what distractors give you for 0% of the complexity, and I think it's great. So let's see what people were saying. Sorry, I was in detached state for a while. Init capacity, oh, right. So I guess I should add defer to my language. Well, I don't know, it depends on you, but I think that you use defer and defer, and you're like, what, 90% there to distractors for free, basically. Does any of this have to do with the data in question? No, not at all, sorry. So when I do these streams, I'm all happy to answer any question about Zig, even if it has nothing to do with the advent of code. So I think this is pretty great, and yes, having it block scoped is like kind of important. For some weird reason, Go doesn't have this stuff block scoped, but it's like it's function scoped. So like if I had this defer runs at the end of the function, so you cannot use this pattern in Go, and then like these defers all get chained, so this would be completely broken. But like, I don't know, you can do weird things with that. In any case, distracted programming streamers, yeah. So, what was I doing? Who am I? Okay, yeah. So line score. Let's compute the line score. So we need to iterate from the end. As I was saying, so Zig doesn't have for loop that works in reverse, so we need to do it ourselves with an index, which is weirdly annoying. So var I usize equals 0, and while I actually wait, I cannot equal 0. Where's I? Okay, I couldn't find I. I think I need to do while I is greater than 0, because we start from the end, right? So we start from line score. No, wait. From stack.items.len. So we start from the end, and while it's greater than 0. No, that's not what I wanted to do. Give me that. Okay, let's see what people are saying. In block scope, you can't assign a variable based on if-else condition. You need to make it null first. In function scope, just assign it instead of if-else. Pop is from the end, isn't it? I would assume so. Matt, as you can see, he's showing, right? He's a subscriber, 15 months, and a moderator, and as you can see, he is the cream of the crop. That's why he's my moderator. So I think that pop goes from the end, but let's double check that. Pop. remove and return the last element from the list. Yes. So it's for doing stacks. So why I is greater than 0, then we want to do I minus equals 1, and then we want to do we want to grab the every time we do this, we multiply line score by 5, so times equals 5, and then we want to add points for the parentheses, right? Switch what? Let's see what people are saying. Stack proportional cap is the solution for this, isn't it? Oh my fucking god, you're right. So you know why I wasn't thinking of this? Because I'm an idiot. I was somewhat thinking of the slice. So stack.items is a slice, right? It's an array. Well, it's a slice that points to an array. And I somehow was thinking of this. I wasn't thinking that, yeah, you can just continue doing stack.pop. Why am I a moron? But now that I'm here, let me show you one thing though. So if you want to iterate in reverse, let's say that you don't have an array, so you don't have iterators, you don't have proportional, you only have a while loop and indices. If you want to iterate from top to bottom, you have a funny problem where you can see that here I'm initializing I to a slightly wrong value, right? This I is not the index of the last item, it's the last item's item plus 1 because it equals to the length, and basically you have to do this because otherwise if you set I to len minus 1 and you set I don't know, greater than or equal to 0, then this underflows, which is a super annoying thing. I mean, you get a panic in normal release modes and in the bug, but it's super annoying. So you have to do everything shifted by 1 and then and I wanted to show this. So you know what? For the purpose of what I'm showing here, the right choice is 100% doing pop, I think, from pop or null from the stack. So like use that approach. But for the purpose of showing this, maybe I should continue with this. Yeah, I think I will. So this goes back to this. So we switch over stack of items, square bracket, I minus 1. And based on what it is, it could be this. Do you have any gripes with Zig? Godwa, is this a question for me? Let me just first double check that that's a question for me. It is, okay. That's a hard question. So I'm probably not the best person to ask this question because I mean, I'm invested in Zig the language, not just as a developer, right? I work at the Zig Software Foundation, so I think that makes my view a bit biased, maybe. Gripes with Zig. So not everything in Zig is perfect. There's a lot of things that are, like, I think not yet there in terms of quality, but the language is like still in being developed. We're not version 1 yet, and so like documentation isn't always perfect. And I mean, the problem is not that we don't want that. The problem is that it takes time and effort to get there, and we will get there. Also, the language is still changing occasionally, so you can't write documentation. Like, you don't want to invest too much in you don't want to, I don't know, write a Zig book and then have the syntax change 2 days later. So that's a problem. So I think that all these issues are, how can I say, reasonable. It's like, I don't think one can demand anything better. Other than that, I honestly don't have any gripe. Like, if the question is about, okay, I asked that knowingly. Okay, so if the question is about strictly the language and its syntax, I actually like everything about it, I think. There are maybe a couple of things that, occasionally I would like to have that are not in the language, but everybody has those. And in any case, nothing like crazy, nothing major. So I'm actually very content with it. But personally, so before I joined the Z Software Foundation, I think the first day I saw Zig, I immediately saw the how comp time works. And I've always been interested in metaprogramming, like since I started university. And so I like Lisp, for example. I like Lisp a lot. And I remember seeing comp time and thinking, holy shit, yes, that's exactly how metaprogramming should be. Why is it not like this? Like, this is like, I somehow had this very fuzzy and vague idea of things that I wish I could be able to do when programming that I couldn't really do because the semantics were sometimes close to and not there, but not really there. And also, I had trouble understanding why metaprogramming in Lisp was so much better. And people say it's because it's homoiconic. But I don't think it's homoiconicity that makes metaprogramming better in Lisp. I think it's something different. And that different thing is enabled by homoiconicity. I'm purposely being vague because I want to give a talk on this point in the future. So I don't want to spoil. I don't want to give a half-baked thought. So that was my perspective for Zig. As for the rest, here's the problem. Like, if there's any complaint about the Zig Software Foundation or of anything else, I don't have any complaint. Like, I've been complaining about like my work all my life, but I seriously have no complaint about the Zig Software Foundation, which unfortunately for everybody else, I guess it means that the Software Foundation is bottlenecked in its quality, but the things that I can do, at least in part. So sorry, but I just love everything that we're doing. So it's pretty cool. By the way, I love reading blogs about Zig progress. Thank you. And if you want to read something that I posted, like half an hour before streaming, there's this blog post, this new blog post, Interfacing with Zig, a BDFL run project. So I think that's another interesting read if you want to learn more about how things work in the Zig community. Look at these people. Beautiful. So let me share the link. So if we find a closing parenthesis, then the points are, I think, 1. I think it was 1, 2, 3, 4, right? This metaprogramming is nice because of runtime evaluation. That is maybe also part of it, yeah, but I don't know. A macro that runs a runtime, it's not as nice as a macro that can run not a runtime, right? At the end of the day, a macro that runs at runtime, it's like just a hack around limitations of the language. Maybe that's a bit unfair to say, but I think that the real punch that macros can carry is doing stuff at compile time. What is the point of a macro that runs at runtime? To be fair, I agree that from an expressiveness perspective, it's nice occasionally to be able to reach for that too, but really, I think that the real point is the compile time. Yeah, so I think this point is fair, and I think that's where homoiconicity comes in. The point is that macros in Lisp don't suck too much, because it's almost as if you're operating on data rather than syntax. Almost. Okay. Let's hope that I'm getting this right. This and this, I think. Let me double check. Round, square, curly diamond. Round, square, curly diamond. 1, 2, 3, 4. And so here, here I need to cast the first element explicitly to a U size, because otherwise the switch won't know what to do. So stage 2, looking forward to not having to do this anymore. But here, so look at this. So I don't know. The first time I saw this, I thought. So if I have a complaint with the language, I think it's this. I think this is kind of annoying. I understand the problem from I don't know how numbers work. I guess how unsigned numbers work. I still think it's so fucking annoying though that I have to offset everything by 1, because if I did the proper initialization, I would get a out of bounds error. And actually, I can show you this. So let me run this. Hopefully, it will run to completion correctly. And afterwards, I'll show you how I break it. Okay, so we compute the score. So we loop over all these things. We append the score at the end, and we start a new loop. While I greater than 0, I minus 1 in the body. Yeah. Yeah, you're right. That's so annoying though. I think you're right. So I can do this. Put it here. That's so annoying though. I think we need a 4 reverse. I don't know, I'm joking. So that solves it, I guess. Yeah, because you do this first. When this gets to 0, then you're good. That's so annoying. Okay, thank you. You opened my mind to a new possibility. So we append, and then we need to sort. We were sorting a while ago, so let's see if we can go grab that. No, not day 8, day 7 maybe we sorted. Sort. Look at this. Oh, and also look, median. That's what I like. Okay, so wait, what? Expected semicolon file identifier, line 40. Oh, is there really no multiply equal? Variables, arrays, pointers. What are the operators? Wait, I'm pretty sure we had an operator table somewhere. Do we really not have it anymore? Oh, operators, okay. So plus, minus, star equal. Okay, so it's something else. Oh, okay, I'm probably blind and missing something. Oh yeah, the freaking semicolon, that's what it is. Yeah, thank you. So, okay, so we sort final scores.items. We sort, doesn't matter which order we are sorting, their U sizes. So it doesn't matter the order because we just care about the median. And yep. And then the result is the median. And that's it. Okay. Oh, I still have some garbage around. So this can be removed. Switch must handle all possibilities. Okay, yes. So copy, paste, save. Okay, expected type, slice of I32, found use size, where? Oh, here. Exact division produce reminder. Ouch. That's not good. Yeah, what's up with add functions? Yes, they're built-ins. So if you see a function that something that looks like a function, it's a function, and it's worst case in the standard library. So you can look at the implementation. It's 100% user-land code. These things with a net, they are compiler built-ins. They're not implemented in Zig. Right now they're implemented in C++. So I guess they will be implemented in Zig eventually, once we switch to the self-hosted compiler. But the point is that these are not actually functions, really. They can do things that normal functions cannot do. So they occasionally don't behave like functions. Like one interesting example, I think, is C import, which takes in a block. In Zig, you don't pass blocks to functions. C import is the only thing that I know of that can accept this, and it's used basically to allow you to do C include, and you can do, like, I don't know, math.h, and now you've included the math C header file. And no first class functions in Zig? Yes, first class functions. You can do that. The problem is, wait, what are you replying? Wait, I don't think that anything that I said should have made you say this. Maybe I said something wrong. Passing in a block to a function. Oh yeah, you can pass a function, but not like a block. I guess you could say like this could be seen as a shortcut to do that, for sure. You can pass blocks normally, they have a value type of void, but yes, import is special, yeah. So import can do weird stuff, and I think import is not the only one. There are other ones that can do weird stuff. The point is, they are not exactly functions. They can do weird shit. Okay, so wait, somebody was saying that it will produce a reminder. Why? Because it's guaranteed odd length. Oh, god damn it, you're right. Shit. So what's the answer? -1? Is that it? You can do a regular A divided by B and floor it. I think that's pretty much what I did. Maybe, we'll see. Yeah, you're right. The thing was, the instruction was saying that there's always a middle element, so. Hey, success. So let me show you what would happen with the other thing. So this is like a bit of a food gun. So you do this and you start at the right spot, and then you run it. God damn it, and it runs. Why? What am I missing? Oh, because I got the wrong condition. Boom, there you go. Integer overflow. Well, underflow, I think that's to be more precise, but yeah. So this is something that you need to be careful of. So let's see. I guess I could help out Zig implement stack discipline closures, but it's a massive undertaking for the type system, at least internally. I think Specs had a proposal in that direction. So Zig macro Specs. I already searched it. Stack capturing macro. So he had a proposal for this. Which was, I don't know. I read it a while ago. I haven't read it for a while, so I don't remember in detail, but I remember it being kind of funky. Okay. I think I'm good. So, does anybody have any question? Do you want me to talk about anything about related to Zig? I think I have still... I still have a ton of time if anybody has questions. Otherwise, I think I'll raid somebody. Doing CryptoPulse with Zig would be fun. Let me search what's CryptoPulse. I don't even know. I mean, I think I can guess maybe. It's like either you have to do crypto stuff or you have... so either you have to like break cryptography or you have to like make a blockchain scheme and sell it to... make a white paper, sell it to stupid investors and then pump and dump as soon as you can. Actual crypto, okay. So you mean the money then? So the site will host all 8 sets of our crypto challenges with solutions for in most mainstream languages, but it doesn't yet. Okay. Qualifying set. Convert hex to base 64. Okay, I see. I think somebody in the community should do this. I don't think I'm the right person for it, but it probably wouldn't be bad. I mean, okay, qualifying set, I think it's... This is like my information theory course. Maybe a bit more. Oh... Jesus, I don't remember. Maybe up to this. I might be too optimistic though. Cool though. So let's see what people are saying. Does Sublime Text have custom plugins? Yes, it does. And I do that. Or let me do remove package, and I do that for Zig. I have a Zig extension installed that gives me syntax highlighting and a couple other things. The thing is, stack allocation simply will not cover all cases of first-class functions. I mean, specs guy. So, by the way, in case people don't know, specs guy is the guy working on the Zig spec. So it's like I never get bored of pointing this out. In any case, so he's Martin. And so maybe he's the best person to talk about this, but yeah, I think I don't think in Zig we really care about all cases for first-class functions. Yeah, because I think it's not just that Zig is imperative, but the thing is also that in general Zig is concerned with the mechanical implications of what you're writing. So it happens oftentimes that Zig is not giving you like the nicest tool from the perspective of writing fancy code, and it tries not to hide how expensive things are in terms of both memory and computational power. With an asterisk, async await, it's a disaster in that perspective, but it brings other things to the table. So yeah. Ratatorsk, maybe you don't care too much about it, but if you are looking for like if you want to, or rather, you're making your own language, so maybe you just care about the discussion from the perspective of making your own language. But from the perspective of having a set of tools that's like complementary and allows you to do both, to drop into the low-level stuff and be super precise about things, and conversely, other times stay up very abstract, but still don't like waste too much resources and like still try to be efficient and everything else. I think the Zig is great in combination with Rock. So I don't know, maybe if you're interested in programming languages, you might have heard of Rock already, but there is a is this it? No, this is a Strange Loop conference talk. There is a talk on Handmade Seattle by Richard Feldman, where he explains how Rock works, and it's basically a language that you can a functional language that you can embed inside lower level languages. So did Abner seriously not link to the videos from the front page media? Okay, this is actually reasonable. That's on me. That's on me. A copy. So I think this is a very nice talk, and he explains how basically Rock makes a bunch of trade-offs to stay high level, way more high level than Zig wants to be, but also try to be efficient and everything else. I think it's a nice combo, like 1-2 punch. So like Zig, low level punch, Rock, high level punch. It's the programming Hadouken. The rule for my language is no implicit heap allocation, that's it. Okay, well, since I think there are no other questions, I think C# has this stack lock concept under the name refstruct, though they use it for safe pointers instead of closures. Well, so since that's it, I think I'm gonna stop here the stream, since I have a meeting in about an hour and 20 minutes or something, and it's an opportunity for me to maybe have dinner. Thank you everyone for watching, and I guess I'll see I'll commit and then see you tomorrow for day 11. So git add dot git commit. Any predictions for day 11? I have no idea. I'm still waiting for the Chinese reminder theorem exercise. I actually don't know if it's there every year, because like my first time doing Advent of Code was last year, but I mean, I don't know. I always have this idea that A star is coming. Oh shit. Saturday problems are always a bit hard. Well, that actually makes sense. Pathfinding problem. Okay, we'll see. Let's see if there's anybody we can raid. Oh, would you look at that? There's this guy live. I think he programs in Zig. Well, see you all next time then. Bye bye.